Still loading flanges manually? Workers stand by machines in 3 shifts. Load 1, remove 1. Cutting time only 60%. The other 40% is pure waiting. 3 pits of manual loading. First, flanges weigh 5 to 6 kilograms. Repeated handling fatigues workers and causes errors. Second, 1 worker per machine. 3 processes need 3 workers. Labor cost is high. Third, loading and removal takes 40% of cycle time. Actual cutting time is less. This line uses 1 robot for 3 machines. Triangular layout, 60 seconds per flange. The robot is fixed at the center, turning to milling to drilling. 3 processes autoflow. 0 human intervention. Equipment utilization above 80%. 3 core stages. First, triangular layout. Robot at center. 3 machines equidistant. Single move 2 to 3 seconds. Shortest travel. Second, cycle balancing. Turning, milling, drilling times evenly distributed. The slow process gets an extra machine to avoid bottleneck. Third, path optimization. Robot uses parallel scheduling, pre-picks blanks while machine 3 runs, arrives at machine 1 just as it completes, eliminating wait time. Watch the demo. Blank arrives from the conveyor. Robot picks and feeds into the lathe for outer diameter turning, removes and feeds into the mill for flange face milling, then into the drill for hole drilling and tapping. Finished part placed on the outfeed conveyor. 3 machines run simultaneously, robot shuttling nonstop. By the numbers, manual loading keeps cutting time at 60% with 3 workers in 3 shifts. The robot solution pushes cutting time to 80% with 1 operator for the whole line. Utilization from 60 to 80%, equivalent to a 33% capacity gain. 1 machine faults, the other 2 keep running. This solution applies beyond flanges, valve bodies, pump housings, motor end covers, and other multi-process machine parts all fit. The key is matching machine counts to process times. Slow processes get more machines, keeping line cycle balanced. The core of 1 robot 3 machines isn't robot speed. It's the triangular layout minimizing travel distance, plus cycle balance preventing machine idle time. Which process is the bottleneck in your machining line?